Hello, I am Danking and I'm going to tell you how to make wired police lights. I have very little time today, so I'm going to go through this very quickly. Just pause and rewind if you lose anything. This is the wired police lights we are going to assemble today. It uses only gates, and when I turn it on, the lights turn on and alternate between blue and red in a very nice and smooth way. And when I turn it off, the lights go off. So let's start. First we need a PHX plastic plate one by one. This is where we are going to assemble our wired police lights on. First thing you need is the button. You can find it under wire input output. Just make sure that toggle is on and value on is 1. So I'm going to place the button here. The next thing we need is the wired timer. You can find it under control, wire control time, and make sure that timer is selected here. So I'm going to place it here. The timer got 2 inputs and 1 output. The 2 inputs are run and reset, where if you input run as 1, the timer will start to count upwards in seconds, and reset if you input 1 into reset. The output will be the time. The next thing we are going to need is a comparison gate greater than. I'm going to place it here. This works if A is greater than B, it will output 1. The next thing we are going to need is the constant value. I have put 3 values on it, 1, 255 and 1000, but for now we are only going to use 1, so let's place it here. The last thing we need is gabe arithmetic rounds. You can find it in the wire control gabe arithmetic, and select, why is my menu so hard on me today, rounds. You can find it here. So let's place it here. Now if we wire that up, I'm going to use the advanced wire tool. Wire run to the button, reset to the greater than, A to the time, and B to the constant value 1, and round A to the timer. So this will happen when I turn it on. The timer counts up. When it hits 1, it's greater than 1, and it will reset the timer. The round gate, when the timer hits a half, it will round it up to 1 and go back to 0 when it resets. So now we have a pulsar. You might be asking why I'm not using the gate pulsar. Well, that's because I can't make it work somehow. So that's why I'm making my own pulsar now. I'm going to put logic gates not inverts. All logic gates only take 2 values, either 1 or 0. This gate will only take 1 input, A, and revert it to its value. So if the round gate outputs 1, this one will output 0, and if this outputs 0, this will output 1. So it inverts the number it gets. The next thing we are going to need is another logic gate, the gate AND. Let's place 2, 1 here and 1 here. I'm placing 2 because we are making 2 lights. The wire AND gate will make sure that the lights turn off when I turn off the button. So let's wire A to the button, and this A to the button. The AND gate works if both inputs are 1, it will output 1. If any of the inputs are 0 or something, it will output 0. The next gate we are going to need is the gabe arithmetic multiply. Let's place one here and here. The gates multiply will multiply all the values it gets. So if I, example, put 5 and 4 into it, it will output 20, because 5 times 20 equals 20. No, 5 times 4 equals 20. Sorry. Let's wire that to and all to the multiply gate, and yes, B to 255. 255 because the lights can only take values from 0 to 255, and when the lights receive 255, the brightness will be at the maximum. The next, let's place the lights now, because it should be working. You can find the lights under wire display. Let's place one here and here. Let's wire that up. The lights got 3 inputs, red, green and blue, and you can mix all of them, of course. First we are going to wire red to the first multiply gate and blue to the second multiply gate. If we turn it on, it should be flashing, but why isn't it flashing? The and all B. Oh, I forgot to wire B, sorry. Wire this B to this round gate, and this B to this not invert gates. Now it will flash between red and blue. To make this light work, just do the opposite. Red to this gate and blue to this gate. As you can see, it's working fine now, but if you want to make it change the colors a little bit more smoothly, keep watching. Let's turn it off. The next gates we are going to learn today is the gate time smoother. The smoother smooths out the value it inputs at the rate you specify. So let's say if I want to smooth out this one is 0. This one is 200 and this one is 255 right now, but since it's off, it's currently at 0. So it will smooth 0 to 255 as nice as possible. The rate is the how fast it will smooth in seconds. So I put 1000, and it will smooth the value it gets with 1000 per second. And since it's only about 250, it will do it in a quarter second. I'm going to wire this rate too up here, and put it to 1000. So let's rewire this thing. Red to the smoother and blue to the other smoother. Do the opposite with the other gates. Red to this smoother and blue to this smoother, and turn it on. Wait, sorry. Now it's on, and you can see they changed the colors very nice and smooth. If you want to debug it, you can of course use screen. I prefer to use this monitor small for this one, only one value, and floor screen value. Place one here and place one here, yes, and wire A from this gate to this smoother and A from this to the other, and turn it on. Now you can see the smooths the values pretty nicely. So let's recap. The button starts the timer. The timer sets its value to the greater than, which resets the timer when it hits 1. Then the time sends its value to the round gate, which pulses the value, and to the NOT gates which inverts it. The AND gate is there to make sure that both values are on, so the lights will turn off. The multiply gate multiplies the value from the AND gates and 255. It then sends it to the smoother and smooths it out with a rate of 1000 before it sends it to the lights. So there you go, your own wired police lights. Enjoy.